Hello everyone, we are from the Department of Electrical and Electronic Engineering. My name is Samruddhi and my teammates are Justin George and Sam Vaiphei. We are presenting the project which is sensorless speed monitoring of BLDC motor.
So this is the motor that we're using. It is a BLDC motor, and then it's an outer rotor type motor, means the rotor is at the outer part of the motor, and then it has 51 windings, and then it has 23 pole pairs which are energizing the coil. And then we also have some Hall effect sensors, 3 Hall effect sensors placed at 120 degree to each other, and then we are going to be collecting the back EMF from the windings of this motor.
Hello everyone, I am going to explain the BLDC controller part. So it's the controller which we are using, which is GK, and its voltage rating is 36 and current is 12 amps. Now I will be explaining the wirings of this controller. Here we can see 2 input, which is DC, which is 36 volt. We are giving input for the controller. Now we can see three wire is coming from the motor, which is high efficiency sensor, which used for for finding the position of rotor, and for powering that we are using one 5 volt supply, which is red and black. Then is this 3 phase which is going to the coil for changing in the 3 phase. What it in at one cycle, one will be at high, one will be at low, one will be at floating. From that floating only we can measure the back EMF, because in the floating point there won't be any other voltage. The back EMF will be appear on floating. Then we are having one throttle pin which it will be doing is just like a throttle. We are having the throttle pin set, which the throttle pin having 3 features, which is connected to the cycle handle, which one is turning on and turning off, and another one is throttle which you are giving, and the another thing is the battery level. And this 3 wire is the responsible for the throttling signal, and this one is the turn off, which we are shorting it. And next pin we are having is light switch, which we are not using for this purpose. And we have brake light, which means that every time it will be showing some voltages, which means that it's applied the brake for the wheel. Then it won't be operating. Now we are connecting it to the ground, then the voltage will be 0 here, which means releasing the wheel. Now it's freely rotating. Then we have one spare power, and we have one pass switch, which is pedal assist system, which means if the rider is using the pedal, means it will sense it, and which will help the rider it will support the rider for bicycling. These all are the pins for controller.
As mentioned earlier, this BLDC motor has 3 Hall effect sensors placed at 120 degrees from each other. The traditional way of sensing speed is whenever the magnet crosses one of the Hall sensors, then its state changes from high to low, and then based on a formula it will calculate the speed that is based on the number of pole pairs of this motor. Now the disadvantage of this method is that these Hall sensors may be susceptible to damage. So to solve that problem, we have used our sensorless method, which involves collecting the back EMF from the windings. That is, we'll tap one of the phases of the motor, and then whenever it's floating, it will take the back EMF reading from that phase, and then it will calculate the speed based on the formula.
So from the 3-phase supply of the DC, we will be tapping one wire connected to the voltage divider circuit, which will reduce the voltage below 5. For the maximum input voltage of the Arduino is below 5, which will be measuring the frequency of the voltage which we are getting from the voltage divider circuit, that will be calculating the RPM from the frequency.